All right, hello everyone. Let's talk about CHAID. CHAID stands for Chi-Square Automatic Interaction Detection. This is a non-parametric statistical analysis that is used for discovering relationships between categorical variables and identifying them into distinct subgroups. The CHAID algorithm, it achieves this by going through a series of steps, which in simplest terms, it begins by finding the best partition for each predictor, and then it compares them to each other. And the best one is chosen, and then the data is subdivided. Each subgroup is reanalyzed to produce further subdivisions. And these steps are repeated until no further factors are found to be significant. So let's take a look at the R environment. I have up here the CHAID package, which I installed because I didn't have it before. It's called CHAID, and it came in from this source, and then I libraried it to bring it in. So we'll just call her in. Then I had already brought my data set into the project that I have going in R, so I just renamed it here to CHAID data. Next, I wanted to look at the structure of the data. This function is similar to the summary function, but it gives a little bit more information like class, length, and content. For example, these are my classes. There's 1,259 observations of 13 variables. I won't be looking at every single one of these variables in my analysis. And it also shows whether it is numerical or character data. So as you can see, most of mine are character. So we can start making some factors. These are the ones that I decided to use. We first have the work interference factor, which is where people indicated how much their mental illness interfered with their work life. I also have gender, I have country, I have a family history of mental illness, a yes or no question for sought treatment for mental illness, and lastly, a remote work question that just asked if they worked remotely at least 50% of the time. So we can run these guys. Cool. And then just to make sure that all these factors are brought in, we're gonna run this. And we find that they're true, so they're all in there. All right, so now let's get into the actual CHAID function. We're gonna start by setting the parameters, and we're gonna call it control for short, CTRL. The function is CHAID control. We'll first set the alpha 2, which is the merging threshold, and it basically is the p-value at which groups will be merged if the p-value for the significant test of those categories is greater. So if the chi-squared test between two categories has a p-value of greater than 0.05, they're going to be merged. So the alpha 4 is similar, but the opposite, as if the significance between two categories is less than 0.05, it's going to be split. So that's the splitting threshold. Then we set the min split, which is the minimum number of observations for a split. So basically there just needs to be at least 2 cases to be split. And then the min bucket is, I also set at 2, which is the minimum numbers of observations in a terminal node. So it will also need to have 2 cases. Yeah. All right, so let's run the model. We'll run this part real quick, and then we'll run the model. So I'm going to call it MHCHAID for mental health CHAID. This is the actual function. CHAID, this is my dependent variable. I went with work interference. My independent variables are gender, country, family history, treatment, and remote work. My data is CHAID data, which I specified earlier. NA action equals NA omit, basically just gets rid of missing data and keeps it clean. And then for control, I'm using these parameters up here. So we can go ahead and pop them in. All right. Now it is time to see it. And to see it, it must be printed and plotted. And they take a second to load. And I'm gonna pop in this second plot. That will also be fun to look at. So first we're gonna look at the printed part in the console. It's got the formula that I specified up here. It has the fitted party and it starts with the root, which it turned out to be treatment. You can see it is subdivided by yes or no. The no treatment group was also subdivided by family history of mental illness, and those are the terminal nodes here. And then on the yes for seeking treatment, it is also a terminal node, meaning it is not subdivided any further. So this is pretty cool. I mean, we can see that people that didn't seek treatment and had no family history of mental illness reported never having, mostly reported never having mental illness interfere with their work. There was a sample of 277 and an error rate of 43.7, which is pretty high. Looks like they're all pretty high. And then people that hadn't sought treatment and do have family history of mental illness said they sometimes did, at an N of 85, error rate of 51.8%. Then on the other side, people that did seek treatment for mental illness said that it was sometimes they felt that their mental illness interfered with work, which is pretty large sample, 633, and the error rate at 433.4. So we've got 2 inner nodes and 3 terminal nodes, as you can see right here, and you will see it again over here. This basically just shows in a pretty picture everything that I just mentioned. It's kind of cool to see the bar graphs of each terminal node and kind of see the distribution. And then I plotted this simple graph, which also shows the same thing as over here in the console, showing the error rate and everything, but it's a little bit simpler. Get it? Simple and cute. Yeah, so that's all I have. Thanks.